Assalamu alaikum and welcome back to the channel. Today we are going to discuss a little bit intro of module 1 Introduction to Nanotechnology. In the introduction we will going to study history and evolution of nanotechnology. When we regards to the nanotechnology, it is a modern and multidisciplinary field that merges the concept of physics, chemistry, bio and engineering. In short, we can say that nanotechnology is a combination of fields. The word nanos originate from Greek word meaning dwarf. In metric system, nanos donate a billionth of a meter, which is 10 raised to power 9 of a meter. When we say about nanotechnology, the nanotechnology is a field which is first originated by the physicist Richard Feynman in his famous lecture where he was discussing the idea of manipulating individual atoms and molecules. In this lecture, he used a phrase, there is a plenty of room at the bottom, which is actually the idea towards the nano, where he is actually showing that atoms and molecules can be at the nano level. The term nanotechnology was coined by Professor Norio in 1974. After that, the advancement in microscopy such as scanning tunneling microscope and atomic fluorescence microscope and many others bring researchers to be able to visualize and manipulate individual atoms, which bring them opening the world of nanotechnology where they can see how individual atoms work at nano levels. After that, we are going to study Introduction to Nanoscale. What is nanoscale? In concerns of material making or any production making, we say nanoscale is ranging from 1 to 100 nanometers. 1 nanometer is 1 billionth of a meter, which is 10 raised to power 9 of a meter. For example, we get a sheet of paper is about 100,000 nanometers thick and a single human hair is approximately 80,000 to 100,000 nanometers wide. Due to this, the materials are differ from their bulk materials. Their physical, chemical, and biological properties were fundamentally different from their bulk materials at nano levels. We can say that this is because of the two major reasons, which are the quantum effects and their higher surface to volume ratio. At nano levels, the surface area is much more available for the materials to act upon as compared to their bulk materials, while the concept of quantum confinement and surface to volume ratio brings nanotechnology to the next level. Quantum confinement, where the size of the material is reduced to the nanoscale, the electrons in the material become confined in smaller spaces, due to which they act differently from their bulk material. We can also say that the confinement changes the energy levels of the electrons and leads to unique quantum effects, which is not present in the bulk. For example, the color of the nanoparticle change with the change in the size and even the chemical composition remains the same. It is because of the resonation of particular wavelength of light observed at nanoscale compared to the bulk scale level where the electron cloud does not resonate. The second major consideration at the nanoscale is surface to volume ratio. At the nanoscale, the proportion of atoms on the surface of a material becomes significant compared to the atoms in the entire material. The smaller the nanoparticle, the larger the proportion of atoms at its surface and the larger proportion of atom at the corners of the crystal. This surface to volume ratio leads to the increased reactivity and other properties like strength, thermal properties and diffusibility. In the upcoming videos, we are going to discuss this concept in details. Thank you.